Okay, so hello everyone, welcome. Can you hear me?
Yes.
Okay, thank you. Okay, just we're
Salam
waiting
alaikum.
1 minute and we start our first session. Okay, so we'll start the session. So basically today is our third number of class. And after completing the 3 hours live training program, then we talk about the problem solving class. Yes. So let me share my screen. And I hope all of you already get the material, mainly the recorded class and also practice code from our Google Classroom practice. So let me share my screen. Can you see my screen? Okay, can you see my screen?
Yes, we are seeing the screen.
So can you see my screen? Is it good?
Yes, we can see your screen.
Yeah, yeah. And laptop. Yes. Thank you. Okay. So basically, today's session, I will try to discuss about this type of topic, mainly calculating any indices from satellite images using Landsat or Sentinel. How we can easily use this satellite imagery, Landsat or Sentinel, and then how we can easily calculating the different types of indices. And after completing this test session, I hope you can able to calculate any kinds of indices, any kinds of equation, or any kinds of formula. You can easily calculate, and then you can get the result using Landsat or Sentinel, both of imagery. You can easily, and you can easily get the result. We also discuss about the filtering and displaying the satellite images, mainly Sentinel-2 satellite imagery, how we can easily filter and displaying the Sentinel-2 satellite imagery, and then how we can monitor NDWI, mainly normalized difference water index or normalized difference vegetation index. Okay? As well as we also try to extract the water body thresholding technique, and it also useful for making the water logging detection or flood monitoring There's a lot of uses to identify or extract the waterboarding using the thresholding technique. We'll also discuss about that. As well as we also discuss about that NDVI, NDWI, or SAVI, or any other indices, how we can easily make the time series chart using Landsat or Sentinel imagery. So previous class I tried to discuss about that, how we can easily make the time series chart for ready-made dataset, how we can easily use the different types of ready-made dataset and make the time series chart. But today's session, I will try to discuss about that, how we can easily use the Landsat and Sentinel imagery and then create the NDVI, NWI, SABI, or any other indices time series chart. How to export shapefile, how to add the gradient, listen, and title on Google Earth Engine, as well as we also discuss about the flood mapping, how we can easily identify flood water body using Sentinel-1 SAR data, and also talk about the monthly time series chart, how we can easily create for NDVI, NWI, or any other time series, any other indices, how we can make the monthly time series chart. Okay, so let's go ahead and start one by one.
Mijan Rahman, I have one question.
Yes, please.
Yeah, you know that in the scripts, how we can make the folders to keep our daily exercises in
Okay,
different
okay, I will
folders.
show you that. Okay, I will
Yeah.
show you. I will show you.
Thank you. Thank you. Thank you.
Thank you. So first of all, I'm going to show you that how we can be filtering the Sentinel-2 satellite imagery. And previous class, I tried to discuss about that Landsat, how we can easily filtering the Landsat imagery. So for the Sentinel, we also apply the same process. Just simply click on the browse data catalog and further open your imagery. Suppose Sentinel, click on here. Then we got all of Sentinel collection. So here you can see about the Sentinel-1, Sentinel-2, okay, Sentinel-3, Sentinel-5, P, Propomi, all of satellite imagery we can get from here. So I want to work for suppose Sentinel-2 multispectral instrument, this data set I want to use. And here we can get this type of satellite imagery. Here you can see the surface reflectance and top of atmosphere reflectance. Both of imagery we can easily get it. Both are the same process when you filtering and visualizing. So in this case, I want to use for suppose top of atmosphere reflectance imagery I want to use, and then further I want to filter. So basically, this Sentinel-2 satellite imagery, it's available from year of 2015 to 2024. This time period, we can easily access this satellite imagery. And this is the dataset provider, European Union, US, ESA, Copernicus. And this is the unique ID about this dataset. Okay, the unique ID about this dataset. And this dataset, we can get the some band are 60 meter, some bands are 10 meter, some bands are 20 meter. Okay. We can see the bands cell size, 10 meter resolution or 60 meter, also get the 20 meter. Okay. So basically, freely available. It's a very good resolution imagery. Can you get the freely available? Okay. This is a 10 meter imagery. We can easily generate using this type of band. Here you can see the blue, green, red, also near infrared. You can see the 10 meter resolution. So this is the imagery. So first of all, I want to import this imagery in my code editor. So simply copy this snippet ID from here and then paste in your code editor. Just like paste here. And further, just keep a variable name. You can put any name as a variable. So let me increase in the screen size. I put the name, suppose Sentinel. Okay, or you can put any name as a variable. So now this is my full image collection. This image collection, I just store it in this variable Sentinel-2. So now this image, I want to filter for my specific boundary for the 2 season. Suppose I want to need the image for dry season or summer season, as well as I also need this image for rainy season or wet season. Further, I want to make the NDWI map, mainly normalized difference water index. And further, I want to check for the rainy season water, how much area increase the water body, the surface water. We also try to calculate this area. So this is my image collection. This image collection I simply import in this variable sentinel2. So now further, I want to import my boundary shape file. So I already show you that how we can easily import our study area or shapefile boundary in the asset tab. So from this asset tab, I simply import my study area, and further I want to filter this image collection for my study area, and then make the different types of analysis. So this is my study area, Dhaka city. I simply click on here. Now it will be import in here in my code editor. It shows as a table. Table is a default variable name. We already know. I put this name as a suppose RY, or you can put any name as a variable. So now I just simply imported two things. One is my study area, another is my image collection. So now further I want to just filtering. So I want to filter. I'll write the comment. Suppose filtering this image collection for suppose summer season. Okay, so I want to filter this image collection for the summer season as well as rainy season. So for that, I just take a variable. Suppose I put the variable name is that dry image, not dry season image. You can put any name as a variable. So now I call my sentinel2 because this variable stored the full image collection. So now this image collection I want to filter for the summer season or dry season. I simply copy sentinel2 and then use here filter bounds. Basically, first of all, where you need this image. I need the image for my region of interest of Dhaka city boundary. Just I use the filter bounds function and then put the variable name as the RY because this is my study area. We already know about that. Then when you need this image, suppose I put this image filter date. When you need this image, I put this time, suppose year of 2020, suppose in the summer season, basically for Bangladesh, this time is that 1st January from year of 2020, 05:30. This is the time for Bangladesh in summer season. Okay, just I put this time period. And further, how you need this image. Suppose I need this image for less than 1% cloud cover. I need this image. Okay, so for that, I simply use that filter metadata function and put here image properties name. You can easily get it the image properties in the data catalog page, image properties. Simply copy the cloud pixel percentage. So simply copy the cloud pixel percentage and then paste here. Okay, and then put here that less than suppose 1. Okay, so now if you want to check it how much image is available in your collection, so simply print the dry image and then check how much image collection are available, how much images are available in your collection. So we can get the 20 images. Okay, so this is the filter metadata function. We already know it's this function mainly useful for filtering the image metadata or image properties. We already know about that. But if you want, you can also use the other function instead of the filter metadata. This function called the sort function. Okay? Sort is another function to filtering image properties. So I want to apply the sort function using this image properties cloud pixel percentage. Just paste here. Okay, I apply the sort function. And after sorting, I want to check how much image I want to bought. So just click to the run. So here you can see now my image collection is also increased. We find out the total 60 images when I apply the sort function. And how I can sort? I want to sort using the cloud pixel percentage. This properties I use and I want to sort, I can get the 60 images. So it increased my image collection. But previous time, when I apply the filter metadata, you can see we find out only for the 20 images. So now in this case, I want to use the sort function and create the composite. Okay. So for that, you can see I just use that filter sort function. Basically, in this time, it including all of cloud level. Okay. Suppose 1, 2, 3. Okay. All of cloud level include in the sort in this time. But when I put the filter metadata, then I can simply put my value. Suppose only for the specific value, I need the images which is the less than 1% cloud cover. I can easily declare this value. But when I apply the sort function, then I don't give any kinds of value. Okay, so it including all of cloud level images and create this composite. Okay, so first of all, we try to make the composite and then check the result, what the situation of our images. Then try to start the retake this. So in this time, you can see when I click to the run, we show the result total 60 images. Okay, 60 images after applying the sort function. So now I want to use all of images and create the mosaic. So in this time, if you want, you can also apply the median. So we already know about the median. Median mainly take the all of images middle pixel value and create the composite. But in this case, I want to apply suppose mosaic. So just put here dot mosaic. Mosaic mainly take all of images and create this composite. Not take any kinds of the median value or mean value or maximum value. Not like that. It take all of images and create the composite. Suppose in this case 60 images it take and create this composite. Cannot take any kinds of median value or maximum value or this type of value. Don't take. Just take all of images and create the composite using the max function. So now I just simply apply the mosaic function and then click with my study area. Suppose study area is the ROI. Okay. So now display the result, what we can get. So just map.add layer, and call the dry image. And also focus the center of this boundary shape file. Map.center object is ROI. Suppose you let it click on. So now it focusing our study area. We got this type of result. So now we try to add the visualization and check what types of image we can want it. Suppose put at the red, then green, and just stressing, and then apply. So now this image look like that. Here you can see it's the totally cloudy image, because in this case we are not filtering any kinds of imagery. We take all of cloud level imagery in this case. So that's why it totally destroy your result, and we can get this type of white pixel. That is now imagery. We can get it. But in Google Earth Engine platform, we can also apply the one Boolean operator. When I put in here, then this type of unnecessary pixel easily removed. Okay, so what is that? We can simply use here that after sort function, just simply use a false function. It's a one kind of Boolean operator. So now all of unnecessary cloudy pixel will be removed, and then we can get the neat and clean image. But this imagery is create composite from total 60 images. Okay, we already checked the how much image is available. 60 images is available. So now all of images we create, and now check the result after applying the Boolean operator of the false. And now I want to check the result.
Excuse me.
Yeah, please loudly.
Yes, can you minimize the full image so we can see the code in full extent?
Yes, please now. Yeah. Oh.
Hello, yes.
Yeah,
I'm
please
asking you if you can minimize the window so we can see the full
Okay,
extent
just
of the codes. Yes.
okay, I think. So I'm connecting the another laptop, so that's why just okay. So now I go with the full code line. Okay. Okay. So now here you can see when I apply the false Boolean operator, then this type of we find out the lot of cloud. Okay, but when applying the false Boolean operator, then it creates the very neat and clean imagery and get it. Okay, so now further I just simply import this visual